Well, thank you. You might want to wait a few seconds with that applause. You don't know what I'm going to say. So you might regret actually starting off that way. There we go. All right. Event-driven, CQRS, DDD, and event sourcing beyond the fairy tale. And eventually, actually, I'm going to talk about microservices quite a lot and how they are not about microservices. And maybe that's one of the answers to what Google should do, right? Make things smaller. Bigger is not always the answer. More is not the answer either. There we go. So fairy tales always start with once upon a time. And for some of you, this may be yesterday, it was a year ago, maybe it's tomorrow, you never know. But once upon a time, we used to build software more or less like this. This is the good old layered architecture that you might know. And to the right, we have a cylinder, and that cylinder holds the most precious thing that our organization has, data. And we want to store that safely, so we store that in a database, preferably a very expensive one. And we don't want people to access that data directly, because you do not trust anyone with your precious data. So we put a box in front of that to protect it. And that box contains the business logic, right? That makes sure that only the way the data is supposed to change is actually happening. But of course, you also have users and you want to present that data in a certain way. So you don't want to mix all of that in the same box, because then you get too many lines of code in the same box and you get all sorts of trouble. So we put another box in front of it. Right? So there's no problem in software engineering you cannot solve by adding a new layer of indirection. So we have this box cylinder or BBC architecture, which has nothing to do with the broadcast company. That's just a very unfortunate circumstance. The problem with this architectural style is that, the problem is the environment has been changing quite a lot, right? We have a rising demand for all sorts of abilities. We have the demand for scalability, elasticity, I had to cheat on this one, flexibility, extensibility, maintainability, all that, right? We've just heard the horror stories of how maintainability works with a code base that is massive. And a lot of the code that we've been writing evolves into what is called a big ball of mud. And here's a reality check for you. It's actually not mud. And in this particular instance, the architect is still on top of it. And the architect is really proud of its creation. It does not really realize what it has built. It is perfectly round, it is exactly as designed, it's beautiful. It's great, and the architect can work with it. The only one. Now, this is probably an explanation where the term code smell comes from. So, as an industry, we've found that microservices to the rescue. 2014, a few books appeared and describing the silver bullet, right? Just make your code bases smaller, make these isolated components that you can quickly change. To Pizza Team, say anything to anyone? They're really good for hungry developers, not for maintainable code. So we have this universal microservices architecture to replace our big monolithic BBC architecture. And now we have little box cylinder style systems, and they communicate with each other. And recently I read a paper, and I was hopeful at the beginning, and then I was very unhappy when I got to the end. And they described this idea that when you have a lot of microservices, you need to organize them. Otherwise, people don't know where to make which change, right? Well, that makes sense. So it's very hopeful. And they suggested that you would have services focusing on the UI, a little bit to the left. And they would talk to groups of services that focus on the business logic. And these business logic services would then in turn use services to capture the state of the system in various components. So basically, overlaying that box cylinder architecture that we saw previously, but now in a distributed fashion. I see some people laughing. I'm very happy that you can still laugh about this. And I think that's particularly interesting. What did we now fundamentally change? Right? We've just taken our big ball of mud and we've increased the number of deployment units. What do you get when you have mud and increase the number of pieces of mud? You get a big pile of the stuff. That's not really a better place to be in, right? It is actually a lot worse. And this is something that we've been talking about for, I mean, our ancestors were already talking about modularity and how to achieve that. But it is something that we should still strive for. But it is extremely difficult. It is actually really easy if you're doing it on a PowerPoint slide. The only thing you need to do is use fancy colors and make sure there's no line in between certain boxes. And then you have perfect modularity. In software, it is a bit more complicated. But we should really strive for building a nice modular monolith first. And there's this saying that if you cannot build a modular monolith, don't even try microservices. Just out of sheer curiosity, who's working on a microservices project or that we would qualify as? Now, keep your hand up. Now, lower your hand if you've not built a decent monolith before. Lower. So keep your hand up if you have built a decent monolith. And now some hands disappear. Congrats, those with your hands up. That's actually more than I expected. I've never built a decent monolith. I've never built anything decent. Oh, it was decent at the time, right? But then you look back at it a few months later and you go, who built this? Git, blame, or annotate, that's it's called. Right, and it was, oh, it's me. Anyway, once we do achieve better modularity, we can then think of microservices and we can think of increasing the number of deployment units. And that part right up there is a much better place to be than there. But it is also very difficult because there's some sort of gravity, which I call anti-modularity forces. And there's some forces at play that really drive us all the way down, that are destructive to our modularity. And some of those are apparently VPs at Google telling you, hey, there's a deadline, right? And you have to meet. So just hurry up. And because of that, we make quick decisions to be able to make that deadline and we build up our technical debts. But it could also be just our misunderstanding of the actual domain that we're working on. There's a certain interpretation we have of the problem we're trying to solve. And as we solve the problem, we learn about the problem and learn that maybe the solution we've built is not the best solution to the problem, or is a solution to the wrong problem. And that's perfectly normal because we are very often pushing the envelope of what we're doing. And it's perfectly normal to not exactly know where you're going to head. And doing a refactoring on the top left, if it is not billions of lines of code, is a lot easier than doing a refactoring on the top right. You might have heard of the reactive manifesto, and this is a diagram from that manifesto. Recently, there was another document came out, the reactive principles, which I can definitely recommend reading. But in this diagram, there's this interesting thing at the bottom. It says message driven. And that's really nice. And some people picked up on that quite well, I have to say. And as a result, we now seek our refuge in events. Right? Anything event driven is good and is going to solve all of our problems. So what we do now is we have this event driven microservices architecture. And basically what we do is we slap this event bus in the middle and just say all microservices exclusively communicate through events. That should solve the problem, right? But of course, we still have UI focused components on the left, business components in the middle, and state storage components on the right. But now they randomly communicate to each other and it becomes really hard to track. But it will solve problems nonetheless. And for some reason, it sounds like events. Well, you have to write down some definition. And since I'm being sarcastic already, This is what it feels like. Magical pixie dust produced by unicorns, used by software developers to make their products scale, perform, and do exactly what the product owner intended. That, anyway, that's for others, right? That's not us. That's how others use it. And for others, it is anything that resembles asynchronous communication. The term event means so many different things in different contexts. It becomes really hard to find out what somebody really does when they say, oh, we're event driven, or we use events. Do you use events, or do your events use you? Now, the promise is that, okay, we've built this monolithic thing that didn't quite work out. So we broke it down into smaller pieces, right? That should solve some of those problems. And then we put events in the mix. And then, yeah, my daughter made me do this. Then it's rainbows and unicorns, right? We're all happy and we happily lived ever after. Unfortunately, if we take that practice, that leads to a big ball of mud. And that just gives us a big pile of mud. Then when we stick events into that, we actually get this. And it doesn't make anything better. We have to fundamentally change something in how we use those events if we want to really make an impact. And this is an example that I slightly rephrased to make it non-recognizable for the original author. It is something that I've seen somebody present, and they were describing their order management system or something similar, and how they work with event-driven microservices. And it starts with the order service that emits an order created event. Well, that makes sense, right? That's an event. It happened, right? That order was created, and it just describes it. And this shipping service picks that up, which is perfectly fine, and then does an inventory confirmed. That's already quite specific, but you could argue it's still an event, right? Yes, the inventory was confirmed. Great. And then the order service sends out an order ready for payment. Now that's awkwardly specific. It is almost as saying, you're sitting at home on your couch, watching TV, and you say, I'm thirsty. That's really awkward, right? There's this nasty intent in that message, and you're not going to make a lot of friends trying to do that. Right? But okay, this is software. Software can deal with it, apparently. So the payment service picks that up and says, order is paid. And then the order service picks that up because it has this asynchronous communication through what they call events. And here we go again, order ready for shipping. Again, it's really specific. Is that describing the actual facts? Well, yeah, you could argue, yes, it is ready for shipping, right? It's the reality, but it's not a very natural way of describing things. And then shipment created. Now, there's nothing bad with this type of communication per se, but it's called choreography. And these components need to know exactly what their part in that particular dance of events is. Right? And if you want to change the dance, you need to instruct every component what they need to do to change it. So making a change in that process becomes pretty complex. Another form is orchestration. And in orchestration, you have the conductor to pass the rhythm, right? Every individual knows exactly what to play. It's just the conductor that sort of glues everything together. And we all know that it's not a matter of one or the other. The best effect is when you combine the two. There's some places for one, there's some places for the other. And we need to carefully think about whether to use choreography or whether to use orchestration when coordinating activities between components. So we have to realize that messages are sent with a certain expectation. The sender has an expectation of how that message is being dealt with on the other side. And as with many things, it helps to be explicit about your expectations. So why don't we apply that to our message-driven? And notice how the term message-driven is used, right? Message. It doesn't say event-driven, and it doesn't say that for a very good reason. Because in messaging, there's actually more than one reason why a component would want to send a message. And an event is one reason, and it is to describe that something happened. Typically, an event is something in past tense, right? Something happened, and I just want to tell everybody about it. Right? But sometimes services send a message to another component to instruct them to do something, such as, hey, I want inventory to confirm the inventory for this order, or I want payment to process the payment for this order. And this is a request for one component to actually do something. Right? So the system needs to be in a state that is different after executing the command than it was before. Right? And the third type of message is a query. Sometimes you just need information. You need information to show to a user. You need to make a decision based on information you do not have yourself. And the interesting thing is that the way you want to route these different messages is different too. So while events are pub/sub, and there's a lot of messaging systems out there that can do pub/sub, commands are more directly pointing at a specific component. Right? That component, I want inventory to actually make a particular change. And queries, you can do different styles queries. I can ask a particular question to a single component. Earlier, I asked you the question, who has been working on microservices? That is what we call a scatter-gather query. You ask a question to a wider audience and you gather all the answers. And I reduce them to, some people have built decent monoliths in the past. So there's a big difference, and we should not conflate the concepts of a message and an event, right? So every time you go into an event-driven system, be wary, right? Is it really event-driven, or are we just hiding different types of messages and all calling them the same? And there's a really nice side effect to using these messages explicitly like that, in that you get location transparency. And location transparency is the concept that two components that communicate do not need to know where they are respective to each other. Are they in the same monolith? Are they deployed separately as microservices, running on the same machine, running on different machines? Is there a massive network in between? Are they scaled up or out? Doesn't matter. The communication is the same. And that means that you can actually migrate from a monolith to microservices very easily. So when we have this idea of some mechanism that works, instead of trying to go straight to microservices, which is really difficult because it's really hard to get the boundaries right, you'll probably just get lost and build a distributed monolith instead. Instead, try to build that monolith and try to find where the actual boundaries are. Learn about the problems that you're trying to solve. And then as you've learned about those problems and found the right boundaries, and you'll find them easily by not having to make any commits on APIs for a while, right? Or only for obvious functional reasons. But once you've got this component really nicely refactored out, you can then extract it. And with that explicit messaging, you don't have to worry about changing the messaging structure. These components, when they're truly location transparent, you can just do that. And then you can evolve further, right? You can extract more components, but more importantly, you can also go back. You can even have hybrid models where certain components are deployed monolithically, but also in an isolated way as microservices in order to meet certain scale. If you have certain components that need to temporarily scale, if you're in retail, there's Black Friday, these self-inflicted DDoS attacks, as I always call them. You might want to store to scale certain components more than others. So when we look at event-driven microservices, they're first of all not really about event-driven in the first place. They are more about messages. And they're not about microservices either. They're more about components. Right? We don't really care how we deploy those components. Are they deployed separately, as in microservices? Are they deployed monolithically? And recently, a very nice term is appearing more and more, which is monoliths. Right? Because the monolith has gotten this bad sound to it. We have this feeling that a monolith is a big ball of mud, right? And we don't want to touch a big ball of mud after seeing those pictures. So we're trying to give monoliths a better name. But there's something about events. There's something that makes them different than the commands and queries, and that is that they maintain value over time. They describe something that happens that might be valuable to remember several years from now. But if we look at systems and what they store, they typically store the information you see here on the right. But on the left, you see a completely different story. Right? On the right, we see somebody bought a chair and sent it back. On the left, we see somebody wanted to buy 2 chairs, changed their mind, made it 1, and then confirmed the order, and then canceled the order after it was shipped. And that's why the return shipment had to be waited for. So the story to the left is much more complete, yet we don't store that. Just imagine the amount of data or the amount of information you actually throw away by just storing the information on the right. The value is on the left. So why not just store that? Why not use that? There we go. And this is where the concept of event sourcing comes in. Event sourcing is about capturing the truth, the whole truth, and nothing but the truth. So help you technology. Now there's a tricky thing about events as the source of truth. Right? So imagine 2 components, microservices, if you will. Now the component on the left probably has a database, and it uses the state in that database to make any decisions. Right? So when there's a request, it will make decisions based on that state. It will update that state according to this decision, and then raise an event to notify other components of a decision that was made. Right? Something happened at that point. So it goes through some message bus, and then it notifies the other component. Now that other component probably also has a database, and then based on the notification, it starts to make decisions as well, and then it updates whatever information is in there. The problem here is that where is the truth? Where is our single source of truth now? These components, the states in that database, the messages that pass through the message bus, and the database on the right, they all tell you a story. Do you know the game called Telephone Game? It's a game that little children play, and you tell the first child a story, the first child passes it to the second one, and the last one tells the story out loud. Right? They do that in primary school mostly, and in banks too. Now it's funny when children play it. It gets really, really messy when us adults and software engineers play it as well inside of our computer systems. Because eventually the last story is not going to be the same as the first one. And instead of it being hilarious, it means consolidation. Building mechanisms to consolidate all the data everywhere and trying to find the actual source of truth. The only advantage you have is you get to pick the most convenient truths out of all 3 and use that going forward. But don't tell the auditors. Now, this is where there's a big difference between event sourcing and event streaming. When we have a service publishing an event onto some event log, but making their decisions off of a different type of storage, and we have another service consuming that event log and then doing whatever it needs to do with that, that's called event streaming. We're streaming the data from one place to another. And there might be a storage in the middle. It doesn't change anything. Now, if that service does not have its own database, but only uses the events it published in the past to make any decisions, then it starts to make consistent decisions, or at least decisions that are consistent with the event log. Right? It's using the information in there to drive any decisions. So any event that you then append was appended with the knowledge of all the messages that were before that. If something happened, it happened because it's in the event log and not the other way around. If something is not in the event log, it simply did not happen. And they're really powerful together. You can actually have one service use their events to do event sourcing and then stream those events because they're a very reliable log of everything that happened. The thing, the whole thing, and nothing but the thing that happened. And the thing in the middle is called an event store. Now, mind you, not everything that stores events is in the event store. Now, this all sounds nice, and there's a lot of technical complexity involved with doing this right? It's not only a mental shift, which, in all honesty, is not easy, but not as difficult as you may think to make. But there's a lot of technical complexity. What about consistency, delivering guarantees, message ordering, etc., etc. Right? Distributed systems are difficult. That's why rule number 1 of distributed system, does anyone know? Don't. Right? A lot of people forgot about that rule, but it is an important one. Try to stick to that rule for as long as you can. Right? It is also the first broken rule of distributed systems. But for that, there is tools that we can use. Tools to help us solve the problems. And of course, there's various tools, some of which look really good on resumes, some others actually solve actual problems. Not saying which. But some of those, I mean, it's not about which tool is better than which other. It is about which one is right for the job that you're trying to do. And I've seen some beautiful implementations of tools that really do a good job, and then they're copied somewhere else because they did such a good job in one place, and they're copied onto another problem. Because if they can solve all problems there, they will solve all my problems too. And be very, very careful. And this really sounds obvious, but prior to my career at Axonic, I was a troubleshooter in projects, and this was one of the biggest problems that I saw. Adding technology causing the complexity in systems to explode. The thing is that we need to focus on practices too. The way we design and reason and talk about our software needs to change too. It is not just tools. Right? Some people jokingly call it, it's not about event-driven systems, it's about being event-driven. It has to come from within everybody. And that sounds extremely like a type of yoga, I guess. But there's something to it. And this is a picture from the Karate Kid. It's a scene in the Karate Kid, which is a movie in the mid-80s. And I don't know if you're familiar with Karate Kid. Yeah, good old times. It was a really good movie at the time, but probably because I was only 6 years old when I watched it. I'm pretty sure it will be a really awkward movie when you watch it nowadays. But there's this gentleman to the right, and he's going to learn or to teach Daniel, the little kid, karate. Right? Daniel really wants to learn karate because there's this girl at school that he really likes, and she's being bullied or hunted after, if you will, by some other guy who's really good at karate. So he wants to learn that. And Mr. Miyagi, to the right, becomes his mentor and says, well, if you want to learn karate, that's great. There's my car, here's some wax, there's a sponge. Good luck. Enjoy. He's like, yeah, but why? This has nothing to do with microservices, right? And it's like, no, but sometimes you need to do the awkward and the nasty things, getting that muscle movement, right? Trying to automate your deployments. Automating deployments is not fun, but you have to do it several times, over and over and over and over and over again. That becomes really, really annoying. Fortunately, we don't have to wax cars. You may if you want to. I'll show you where mine is. But in our industry, we have things like domain-driven design. Try to read that book over and over and no, don't. If you read it once, you deserve a medal. It's a really big one. It's actually a very old book. I still recommend reading it. It really changed my perception of how to approach software engineering, how to look at software in general. But there's also some practices that we can use, and the two I like a lot are event storming and event modeling. And these practices both take events as the first step. Describing a system, either its desired state or its current state, whichever you want to start with, describing it as, okay, what happens in the system? And force everybody to First of all, stand up, put stickies on a wall, but think in past tense. And think in terms of facts. And when you do that, you get a whole different view on how to design and build a system. Event modeling is similar, is a bit more focused towards building actual computer systems, whereas event storming is very general. Right? There's this term social technical systems, right, where we recognize the fact that humans are part of our system too. And event storming is really good at taking the human part, including the human part in the entire system. Whereas event modeling is more focused on what kind of UIs do you have? What kind of information does that UI need? What actions do the buttons trigger in the system, etc. That's as far as I wanted to go today. If you have any questions, there will be time in the panels, I understood. And otherwise, I do have my laptop with me. So if you want some actual stuff in reality, really beyond the fairy tale, because now it's been a story where they lived happily ever after at the end. But yeah, do ask if you want a demo. Thank you.